Now we're going to be studying the hydrolysis of imines and enamines. So, but I want you to see that this reaction, how do we form imines? This is an imine, and below is an enamine. And we form imines with the reaction of a primary amine, and this is pH is mildly acidic, so between 4 and 5. And so you will do an imine. So from the carbonyl compound reaction with a primary amine. Now, if the amine is secondary, you will form an enamine. So I'm going to do the mechanism first for that, and then we're going to be doing the hydrolysis of imines and enamines back. But let's first form it. So there are a couple of ways in which you can do that. But in all cases, the pH here to form these products is between 4 and 5. So it's mildly acidic. The reason for that is that if the pH is too acidic, say that this is a primary amine and you have acid, and it's, again, if the pH is too acidic, then you will have the protonated amino, which is not nucleophilic. But on the other hand, when you have a small, say, pH is mildly acidic, you can still have the carbonyl compound in a small amount protonated. And so the reaction, a protonated carbonyl compound is more reactive than the unprotonated. So the fastest reaction will occur between the nucleophile, so the amine in the free form, I'm going to say like the free amine, and the protonated carbonyl compound. Again, this is your nucleophile, you need this, but in moderate acidic conditions you will have that, and this is more reactive than this. So now let's draw the mechanism between these two. So if I have already that proton transfer here, I'm going to do the nucleophilic attack by my primary amine. That was formal positive. And now I'm going to have OH, and I will have N, H, H, and R. So I will have this with the formal positive charge. So next up, you will be, say that you have water or even the another molecule of the amine. So this is more basic, so I'm going to do that. The amine is more basic, but so you will have this, and then you're controlling the pH so that you always have free amine. And so, and that you will get here this compound, which is NHR, NOR, and this is called the carbonyl amine. So you have this OH in the amino group. So next, when I'm doing that, is I'm going to protonate the O. So yeah, we know that that's a lot of steps. I'm not going to do that this time overly like I did in this steps already had it protonated. And now I'm going to form this double bond, and water is a good leaving group. So I'm going to have N, H, and R, and this is formal positive. And let's say, well, we will have a base, either water, say, of the amino, to take this. And this is my imine that we have right here. Notice for the reaction to occur, and so the first step is like a nucleophilic addition, as all the reactions with aldehydes and ketones. Nucleophilic addition, but right here I have a dehydration, so minus water. That's what give me the imine. But what we need to see here is that we can form imines with primary amine, because here I had two H's. One was removed in the first step to give me the carbinolamine, but I already had another. And in the final, this is the protonated imine. I've removed the second, so now we need this two. Here I have two, and now I have only one, and I remove it. Okay, in the case of the enamine, the difference is that we don't have, we only have one H. What this is I cannot do those two proton transfer steps. Okay, got logged out. Okay, so notice primary amine has two H's, the secondary has only one. So now, to say save a little bit of a space, I'm gonna change the amine here by a secondary amine. And in doing so, well, now I'm going to replace this by an R group. Now it's a secondary amine. And now I have two R's. And still you form a carbinolamine. And still you will do this step. But now, you don't have, when you form the species here, has two R groups. So I can no longer have that. So what happens in the case of a secondary amine, notice all I did is I was erasing one H and replacing it by R. And so I had two R's here, two R here. I formed that. What is a good living group? I formed that. But that I can no longer have the proton removing steps of the proton transfer at that position. But instead what happens in the case of the enamine is one hydrogen at the next position is a hydrogen that's removed. So let's say now a base will remove this. So say it can be water, of course, or the amino. Now I'm going to form a double bond, and I'm going to move those electrons over. So as a result, the double bond is now here. And this is what we call the enamine. But another thing that we want to notice now that we're doing problems is that all these steps are reversible. So the enamines and imines, this is reversible, so I can hydrolyze an amine to the carbonyl compound and the amine, or I can hydrolyze an enamine and back to the carbonyl compound and the amino. And this is what we're going to be doing.